In this video, I'm going to be talking to you about compound interest. When you invest money in a bank, the interest is rarely paid at the end of the investment. Usually, the interest is paid periodically, and the amount that's invested increases by the amount of interest that's been paid. For example, if you had a $1,000 investment that was earning 6% interest, compounded monthly, what that means is each month, whatever 6% interest for that month, for that period of 1 month is on the principal amount, $1,000, that amount of interest will be added on to the principal amount. The easiest way to explain it is to show you in a table where we have the starting amount, the interest, and the balance. So for the first month, the starting amount would be $1,000. The interest that we would earn over the course of 1 month at 6% interest is given by the simple interest formula, PIN. So that would be 1,000 times the interest rate, 0.06 times the term, which is 1 month, so it would be 1/12. So we put that into our calculator. 1,000 times 0.06 times 1/12. And we get $5. So the balance at the end of the first month will be $1,000, what we started with, plus the $5 interest, which is $1,005. Now what will happen is, at the beginning of the next month, so for month 2, our starting amount will now be $1,005. That's the amount that we'll calculate the interest on. So the interest will be PIN, which is $1,005 times the interest rate, 0.06, and we're talking about a single month here. So if we put that in our calculator, we'll get 1,005 times 0.06 times 1/12. We get $5.025. So the interest that we earn in the second month is slightly more than the interest that we earn in the first month. So the balance now of the investment will be what we started with, $1,005 plus 5.025. So now we'll have 1,010.025. So at the beginning of the third month, we'll have 1,010.025 as our starting balance. The interest that we earn will be 1,010.025 times 0.06 times 1/12. When we put that in our calculator, we get $5.05. So we can see then that at the end of the third month, our balance will be $1,010.025 plus $5.05. So we'll be left with $1,015 and about 8 cents. So as you can see, each month the balance is going up, and each month it's going up by more and more, albeit ever so slightly. Now, working out each month and transferring the balance at the end of the month down to the starting balance for the beginning of the next month is all very well if we only have a couple of months. But if interest is paid daily, for example, and we have an investment that goes for a year, we'd need to calculate a new balance for every day of that year, which would be fairly cumbersome. There's a simpler way of calculating the final balance, and that is to use what we call the compound interest formula. The compound interest formula has the following components. We say A, just like for simple interest, is the amount to be paid back either to the investor at the end of the investment or to the bank over the course of the loan. P, just like in simple interest, is the principal. That's the amount that we start with. I is the interest rate as a decimal. And we're going to introduce two new terms here at compound interest, which will be K, and that's what we call the rest period, and we'll use the letter T to represent the term of the loan in years. Before we go on, I just want to explain what this rest period is. The rest period is the frequency at which the interest is paid. So in our previous example, interest was paid each month. So the rest period would be 1 month. It's the number of rests in a year. So for example, the number of rests in a year, if the rest period was 1 month, would be 12. So what might be better is actually to say, instead of saying the rest period, is actually to say the number of rests in a year. So for an investment that's compounded monthly, K would be equal to 12, because there's 12 months in a year. For an investment that's compounded weekly, K would be 52. Compounded daily, K would be 365, and so on. We could have a loan or an investment that was compounded biannually, so every half year, quarterly. So if we said compounded quarterly, then the number of rests in a year, if it's compounded quarterly, would be 4, because there's 4 quarters in a year. So that's what the K value is. It's the number of rests per year, the number of compound periods that occur in a full year. So now we'll get on to the compound interest formula. Unlike the simple interest formula, the compound interest formula is expressed in terms of the final amount. So we say the final amount is equal to the principal outside of 1 plus I on K to the power of KT. So let's do an example. Let's do the example that we use to demonstrate compound interest right at the beginning. So $1,000 invested at 3% compounded monthly for 3 months. So just like with simple interest, what we'll do is we'll highlight the various different elements of the question. So the question is asking us to find the amount, the term of the investment is 3 months. So T will be equal to 3/12. The interest rate, I, will be 0.03. This is an investment that's compounded monthly. So K, the number of rests per year, will be 12. And the principal amount is $1,000. Now that we've identified each of the variables, it's a simple matter of writing the compound interest formula and then substituting into that formula the values that we have. So start with $1,000. The interest rate 0.03. The number of rests per year 12. And then KT will be, K is the number of rests per year, 12. T, the term of the investment, 3/12. Then we can pop that in our calculator. It's very important in entering these this equation into our calculator that you get everything just right. So we're going to have 1,000 times, open brackets, 1 plus 0.03 over 12. I've just pressed the close bracket there, and you can see that the bracket has closed on the denominator of the fraction, which is not what we want. So we'll just move forwards one space and close the bracket there around that whole part of the expression. And now we're going to use the index button to raise this whole part of the expression to our index, which is 12 times 3/12. And again, I'm going to move forwards before I close the bracket. It's important that you do enclose this whole index in brackets, otherwise you're going to get an incorrect answer. So our formula gives us an amount of $1,007.51, 52 cents for 3 months. And that's compound interest.